Yes, good morning, children. Let us go with solid state further. Imperfections in solids. Now, what is an imperfection? Why does it arise? Okay, that's what we are going to see here. And the different types of imperfections present in solids we are going to discuss. Imperfection in a solid, it arises due to two important things. One is presence of impurity. Okay, if there is any impurity is there, then the solid may show some kind of properties which are different from the original one. Then it may also be due to improper growth of the crystal lattice. If the crystal is not having the same type of arrangement as it is supposed to be, then also it may show some imperfection, right? So presence of impurity and improper growth of crystal lattice this may cause imperfection in a solid lattice. Now what happens? What is the result of this imperfection? It modifies the properties or it may impart some new properties also. Okay. Now for example, I can give you presence of impurity in silicon, which is otherwise an insulator. Because of the presence of impurity, it becomes a semiconductor. Is it not? So there is a big advantage also due to the presence of impurity in a particular substance. Right? Okay. Now presence of impurity. How we are going to see? They are going to be called in terms of defects. Now these defects, what are the types of the different crystal imperfections? Defects are of two types. They are point defect and line defect. Okay. Now line defect is due to some kind of displacement or dislocation in the complete row. That is called as line defect. When a crystal lattice is arranged on a particular plane, if there is any disturbance, that is called as line defect. Now point defect, the name point itself is telling you giving you some indication that some missing things are there. Point at a particular point. Now this point defect only we are going to see in detail here in this chapter. Point defect is of basically three types: stoichiometric defects, non-stoichiometric defects, and impurity defects. Okay. Now this stoichiometry means what? Measurement. Is it not? Stoichiometric defects is again of two types. Two types in the sense that if the stoichiometric defect is present in ionic solid and if it is present in non-ionic solid. How would you say that? If the stoichiometric defect is present in an ionic solid, then it is of two types, Schottky and Frenkel. And if the same stoichiometric defect, if it is present in a non-ionic solid, it is called as vacancy defect and interstitial defect. Okay. So basically this vacancy defect is same as that of Schottky defect and interstitial defect is same as that of Frenkel defect. Right? Just because it's a non-ionic solid, the names are different, but basically the things that they exhibit, they are almost the same. In non-stoichiometric defects, it is again of two types. You have metal excess defect and metal deficiency defect. And then impurity defect. This is again of two types, again based on the type of solid. That is doping. Doping is nothing but introduction of an impurity atom in a particular substance. That is called doping. Okay. Dope test you must have heard, especially in athletes or players. Okay, those who take something to improve their muscle power. So here something is added. What is that? Doping in ionic solids and doping in covalent solids. Doping in covalent solids is again of two types. if you introduce an electron rich impurity, what does it show? And if you are introducing an electron deficient impurity, then how it behaves. Okay, so this is basically in terms of semiconductor. In the case of silicon, if you are introducing, say, phosphorus as an impurity or arsenic as an impurity, then how does it behave? And if you are introducing boron as an impurity or gallium as an impurity, then how does it behave? Now, why do you call it as electron deficient or electron rich? That is because, see, the basic host lattice is that of silicon. Now, silicon is having a configuration 284. That means 4 valence electrons are there. But the atom that you are introducing as an impurity, say phosphorus or arsenic, they belong to group 15. That means they have 5 valence electrons. Okay, so the impurity atom is having more number of valence electrons than the host atom. So you call it as electron rich impurity. Whereas here, the same silicon lattice, which is having 4 valence electron in it, if you are introducing boron or gallium as an impurity, boron is having 3 valence electrons. Silicon is having 4 valence electrons. Okay, so when you are introducing an atom which is having lesser number of valence electrons than the host atom, then you call it as electron deficient impurity. Okay, now this is basically in terms of semiconductor. This will also give rise to a semiconductor. This will also give rise to a semiconductor. This will give rise to a semiconductor which you call it as N-type. N-type semiconductor. N denotes electrons, negative, right? Because there are excess electrons in the impurity atom. Whereas this electron deficient impurity, if it is introduced in silicon, then it results in P-type semiconductor. P means positive. That means the impurity atom is deficient in electron. Okay, that creates positivity, or you call it as P-type semiconductor, right? So this is what we are going to discuss a little bit in detail about all these things, right? Okay.